Hi dear students, today I am going to explain AS level question. An archer draws his bowstring back to position X. The bowstring and arrow are shown. The tension T in the string is also shown. Then he draws the bowstring back further to the position Y. The archer finds the resultant force on the arrow is greater when the arrow is released from position Y. What's the increase in force? Firstly, you must know that in this type of question, we will apply trigonometry. We have two tension force here. They are equal to each other and they applied at the angle. And this is the R. This arrow is our resultant force. And we will find that this resultant force according to trigonometry rules. And firstly, I will draw that straight line. And this is perpendicular to our resultant force, and as you see that this resultant force, it will be adjacent side of our triangle, and this is at our angle here. So this side, adjacent side, it will be equal to tension force multiply cosine theta over 2. Why theta over 2? Because overall degree 120 and this resultant force, it will be divided to place. That's why 60 degree and 60 degree it will be. And so we have also a second tension force. That's why I will also draw that straight line perpendicular to the resultant force, and our angle is here. Again, adjacent side, it will be our resultant force. So plus, why plus? Because we have two force in the same direction. That's why resultant force, it will be equal to sum of them. Tension force multiply cosine theta over 2. That's why resultant force here, it will be equal to 2 tension force cosine theta over 2. And I wrote this equation for the position X, but the same equation, it will be also for the position Y. Now I will calculate that force for the position X and for the position Y. For the X position, okay, it will be as in this form, force equal to 2 times tension force in the X position 110 times cosine, here it will be 60 degree. So answer is 110 Newton. For the Y position, okay, F equal to 2 times, here tension force is equal to 150 multiply cosine 45 degree. Answer is that 212 Newton. And question is that increase in force. That's why we will find that difference of the force. 212 minus 110, the answer it will be 102 Newton. And answer it will be C here. Let's move to the second question. In the second question, the diagram shows two fixed pins Y and Z. A length of elastic is stretched between Y and Z and around pin X, which is attached to the trolley. X is at the center of elastic and the trolley is to be propelled in the direction P at the right angles to YZ. The tension in elastic is 4 Newton. What's the force accelerating the trolley in the direction P when the trolley is released? Again, this is also, we must apply trigonometry rules. Why? Because we have two tension force, X, Y and X, Z. They are equal to each other and also their lengths equal to each other. Our resultant force, it will be P. Okay, and now I will apply trigonometry rules. This is that our resultant force. As you see that it's also our adjacent side in our this triangle. And so this adjacent side, it will be equal to tension force multiply cosine theta. Again, we have This is also 4 Newton. This is also 4 Newton. We have two tension force. That's why also second one adjacent side, it will be our resultant force, and we will find it some of them as a final resultant force. So it will be plus tension force cosine theta and 2t cosine theta. Now I know that tension force is equal to 4 Newton, but I don't know the cosine theta. Our angle, it will be here. Okay, so cosine theta, it will be equal to, we know that length of adjacent side, they gives us 30 millimeter here. And also we know that hypotenuse is equal to 50 millimeter. So 30 over 50, 3/5. This is that r cosine theta. And I will put the same numbers to here. Final resultant force, it will be equal to 2 tension force cosine theta. 2 times tension force, they gives us 4, multiply, instead of cosine theta, I will write this 3/5. So answer is that 4.8 Newton, and answer will be C. I hope this explanation is clear for you. If you have question, you can send me.